Section 5.4 is dividing polynomials. We have two ways that we're going to learn how to divide polynomials. One of them is called long division, and the other one is called synthetic division, or like synthetic kind of means fake division. Long division is something that you already know how to do. You learned how to do it in like 4th grade. Before we get into long division, I want to maybe make you realize something that you didn't know before. When you divide, you wind up getting two factors. What you divided by times what you got will give you what you started with. Division undoes multiplication. What undoes FOIL? Unfoiling? What undoes the distributive property? If I distribute something in, if I want to undo that, what do I have to do? Factor. Factoring undoes the distributive property. If I have two things that I multiplied together, I can undo that multiplication by factoring those two that thing back out. If I multiply, I can undo multiplication by dividing. Division is simply factoring, written a different way. That's all it is. Okay? Division is multiplying in a different way. So division is just factoring. And factoring is just undoing foiling or distributing. So long division. That's what we're going to do first. And first you need to realize that what I have written here on the one side of the equal sign is exactly the same as what's written on the other side of the equal sign. On this side of the equal sign, what is that symbol right there? That's the division symbol. The elementary division symbol that you first learned how to use. We have lots of other division symbols. We're going to bring another one back from the dead here pretty soon because we're going to be long dividing. It's going to be awesome. But what this means is this thing divided by this thing. And this means exactly the same thing. This thing divided by this thing. What we have written here is a fraction. Fractions are just division problems that haven't been done yet. This is a division problem that hasn't been done yet. So all along, ever since you've been writing fractions, 3/4, 2/5, that's just a division problem that hasn't been taken care of. The same thing is true here. If I have, this is an aside, but if I have 5 halves as a division problem, I can rewrite that as 2 1/2. Because 2 goes into 5 twice with 1/2 left over. There's a remainder of 1/2. When you learned long division, you did 2 divided into 5. Well, 2 goes into 5 twice. 2 times 2 is 4. We subtract. And I'm left with the remainder of 1. In the 4th grade, you would write R1 here. But in like the 6th grade, you realize that you could take the 1 and put it over the 2 and be left with your remainder of 2 plus 1/2, or just 2 1/2. That's where mixed numbers come from. This is what we're doing, except with this. Okay, so what I want you to do is try to perform long division just like you learned how to do in the 4th grade. Maybe this isn't 4th grade, I don't know, I just guessed. But I think it's probably about 4th grade that you learned long division. So we have 672 divided by 21. How do I set that up? Using long division. Not using the tree, not the upside down thing. Yeah, we want the actual division symbol that we used back in 4th grade. It's not a square root, so make sure you're not drawing a square root. The denominator goes out front, and then the numerator goes inside. And then what you do is you say, how many times does 21 go into 6 evenly? Well, 21 doesn't go into 6 evenly. So I skip the 6 and I make it 67. And I say, okay, how many times does 21 go into 67? 3 times. So I write that 3 above the 7 because that's as far as I have gotten so far. And then, what do I do? Where did the 63 come from? You multiplied. When you multiply, you're actually, I don't know if you know this or not, distributing. I take the 3 and I multiply it times the 1 and I get 3. I take the 3 and I multiply it times the 2 and I get 6. So I got 63. And then what do? Subtract. 67 minus 63 is 4. And then what happens? Bring down what I'm left with. I have this 2 sitting here, so I bring that down. Now what do? How many times does 21 go into 42? Twice. So I put the 2 there, and then I distribute again. 2 times 1 is 2. 2 times 2 is 4. And then I subtract, and I get 0. So that means that 0 means what? There's no remainder. So in other words, 21 goes into 672 evenly. It goes in exactly 32 times. So that means I could take 21 times 32, and that should give me 672 if I multiply those two things back together. We are doing exactly the same thing with polynomials when we divide polynomials. Set up the long division problem. So we're going to have still the division bar, or the division symbol there. The denominator is still going to be written out front, 2x plus 1. The numerator is still going to be written inside, 6x squared plus 7x plus 2. And now just like we did over here, we said 21 times what gives me 67, or close to 67. What I'm going to do over here is I'm going to take just this term right here, 2x. 2x times what gives me exactly 6x squared? 3x gives me exactly 6x squared. So I have 3x. I'm going to write that directly above the term that has the same degree. Since I'm thinking 3x, I'm going to write it above my other x term. So I write it right there, 3x. No. Trust me. Now, what did I do over here once I wrote that 3 down? I distributed. So I'm going to take my 3x and distribute. 3x times 2x is 6x squared. Then 3x times 1 is plus 3x. Then what did I do over here? I subtracted. Now this is the tricky part, and this is the part where I'm going to kind of branch away from what we have written here, where we just subtract, because we understand how to subtract this. The tricky thing is, if I just say subtract, then most of you will remember to subtract here, but a lot of you will forget that this also has to be subtracted. So what I'm going to do is, instead of saying subtract, I'm going to say change all the signs, and the way I change all the signs is minus there and minus there, and then I'm going to instead add, because subtraction is nothing more than the addition of the opposite. So if I change all the signs and add, it's the exact same thing as subtracting. And that prevents me from making the silly mistake of forgetting to subtract here as well. So 6x squared minus 6x squared is 0. It's gone. 7x minus 3x is 4x. So I write down the 4x just like I wrote down the 4 over here. And then what do? Drop down the plus 2. So you automatically already kind of understand how to do this problem. We drop down that last term. Now I do the same thing. Ask yourself, 2x times what gives me 4x? The answer is 2. I'm going to write that directly above the other constant term. And that was a 2, which is positive, so I'm going to write plus 2. Then I distribute. 2 times 2x is 4x. And then 2 times 1 is positive 2, so I write plus 2. And then I'm going to subtract by changing all the signs and adding. 4x minus 4x is 0. 2 minus 2 is 0, so I'm left with 0. Which means that 0 means that I have no remainder. So it went in evenly, that's right. So therefore, this fraction right here reduces to this answer. That's my answer. If I wanted to check that, then I would just take my 2x plus 1 times my 3x plus 2, And I should get exactly 6x squared plus 7x plus 2 as my answer. So if I FOIL that back out, I get 6x squared plus 4x plus 3x plus 2. Combine like terms, that's 7x right there. So I get exactly the same thing back. It is cool. In these examples, the remainder was 0. What did we do if we had a remainder? You make the remainder a fraction. So if this was like a 4 here in 4th grade, you would come up here and you'd write R4. But then in like 5th grade or something, you would take that 4 and put it over the 21, and instead you'd have 32 plus the 4 over 21. So it'd be 32 and 4 21st would be your answer. Over here, if we had a remainder, we'd do the same thing. We'd take the remainder, whatever it is, put it over the thing we divided by, and then write it over here as a remainder. So we'll write plus, or if this was a negative number, we'd write minus, and then that number divided by what we divided by. We'll see how that works in the next example, I think. So let's try this one. 4x squared plus 23x minus 16 divided by x plus 5. What am I going to do? Draw the little thingamabob. Now what? What goes outside? X plus 5. And then inside is the 4x squared plus 23x minus 16. That's the setup. Now, how do I go about doing this problem? Find something that equals what? What am I saying to myself as I go about doing this problem? What times x, this first term, gives me 4x squared? And the answer is 4x. So I'm going to write that where? Above the other x terms. So I'm going to write 4x there. Now what do I do? Distribute. So 4x times x is 4x squared. And then 4x times 5 is positive 20. So I write plus 20x. What happens now? Change all the signs. So we're going to subtract. Really, we're subtracting. But to do that, we're going to change all the signs and add. So this becomes 3x. What do I do now? Bring down the minus 16, and then I do it all over again. What do I do? Good. What times x gives me 3x? 3. Just 3. So up here, I'm going to write what? Plus 3. And then distribute. 3 times x is 3x. 3 times 5 is 15, so plus 15. Now what do I do? Change all the signs and add. Change all the signs and add. 3x minus 3x is 0. It's gone. Negative 16 plus negative 15 is negative 31. It's very easy to think that that should have been negative 1. But it's not, because we changed all the signs and we added. So be careful there. Okay, so this time we're out of terms. We do have a remainder. So the way that I handle that is I take the minus sign that I see, and up here I'm going to write minus. And then I take the number and I put it over what I divided by. And that is my answer. If you don't put the minus sign here, then you're going to put a plus. And then that 31 will remain negative, which is also perfectly fine. That's an acceptable answer. The book, though, is going to do this. It's going to take that sign and put it there. And then the number itself there, divided by what we divided by. Think 2 practice problems is enough? You can do one on your own? All right, try this one on your own then. I'll go ahead and set it up. Talk me through it. What times x equals 3x squared? I get, and I'm going to write that here, 3x. Now I distribute, so I get 3x squared minus 21x. Now what? Change all the signs, so negative here, positive here, and then we add. This becomes, and I get negative 8x. What happens now? The positive 56 comes down. Now what? What times x gives me negative 8x? Negative 8. So I write up here minus 8. So now negative 8 times x is negative 8x. Negative 8 times negative 7 is positive 56. We change all the signs and add, and we're left with 0. So is there a remainder here? No. So this one actually did divide evenly. X minus 7 times 3x minus 8 is this polynomial right here. There's probably something kind of important that we need to talk about. Little important. Actually, it's extremely important. All of your terms have to be accounted for when you do long division, and later when you do synthetic division. If you have missing terms, so like for example, in this polynomial right here, 3x squared, if this middle term was missing, if all I had was 3x squared plus 56, when I set this up, I have to include all of the terms that I'm supposed to see. So I have the second degree term, I have to have the first degree term, and I have to have the constant term. If they're not there, then I have to include them with a coefficient of 0. So if there was no x term, I'd have to write 3x squared plus 0x plus 56. Every term has to be here. Otherwise, your division process will fail. Another way that you can be shown a long division type problem is if you're asked to do something like this. It says, is x squared plus 1 a factor of that polynomial? The way that you're going to do that is by setting up long division. So what they're asking you to do is this. This on top, 3x to the fourth minus 4x to the third plus 12x squared plus 5, divided by x squared plus 1. If x squared plus 1 is a factor of that polynomial, we will do that long division and wind up with a remainder of 0. So to set up this long division problem, the denominator is still going out front, x squared plus 1, and inside still goes the polynomial, but I have to remember that important safety tip that I gave you guys just a little bit ago. Every degree has to be accounted for from the top on down. So I have 3x to the fourth. I better see x to the third, x squared, x, and the constant. I have 3x to the fourth. I have minus 4x to the third. I have plus 12x squared. But I'm missing the x term. So I'm going to have to include it by saying plus 0x and then plus 5. Now, like I said, if x squared plus 1 is a factor, then once we're done dividing, we will have a remainder of 0. So let's divide. This process is the same. Even though I see x squared sitting right here, I'm still going to do the same thing. What times x squared gives me 3x to the fourth? 3x squared. Now I'm going to write that above the x squared term. So I'm writing it all the way over here. 3x squared. You always go above the same degree term. So now I distribute. 3x squared times x squared is 3x to the fourth. 3x squared times 1 is 3x squared. And I'm writing it under the x squared term. Draw my line, change all my signs, and add. The 3x to the fourth minus 3x to the fourth is gone. But this term plus nothing is still that term. So it comes down. Then 12x squared minus 3x squared is plus 9x squared. And then I bring down everything else. Plus 0x plus 5. Now repeat the process. What times x squared gives me negative 4x to the third? Negative 4x. And I write that above my linear term. So minus 4x. Negative 4x times x squared is negative 4x to the third. Negative 4x times 1 is negative 4x. So I'm going to write that below my x term, minus 4x here. Draw my line, change all my signs, and add. The x cubed terms go away. The 9x squared term sticks around. 0x plus 4x is plus 4x, and then plus 5. Do it again. X squared times what gives me 9x squared? 9 only. So plus 9. Now 9 times x squared is 9x squared. 9 times 1 is 9. Change all my signs and add. The 9x squared disappears. The 4x comes down. I get minus 4 here. I'm out of terms. So I'm done. Therefore, this is not, to answer the question, is x squared plus 1 a factor? The answer here is no. The answer that I got was 3x squared minus 4x plus 9 plus the remainder, 4x minus 4, divided by x squared plus 1. So depending on how they ask you the question, is this a factor? We got no. They could just say, divide these two, and if they did, then this would be my answer. If this was a factor, then they're going to say, if it is, write it as a product of two factors. So that's where we would write this thing times the answer that we got. P of x equals the factor times the factor. You think we could do that second one quickly? Okay. We have x minus 2. Is it a factor of x to the 5th minus 32? So that's x to the 5th minus 32 divided by x minus 2. Set up the long division. We have x minus 2 outside divided into x to the 5th. And look at all those terms that I'm missing. So I got to put plus 0x to the 4th plus 0x to the 3rd plus 0x squared plus 0x, and then finally minus 32. Every term has to be accounted for. So now I'm ready to go. Long divide. X times what gives me x to the 5th? The answer is x to the 4th. So I write it here. X to the 4th times x is x to the 5th. X to the 4th times negative 2 is minus 2x to the 4th. Draw my line, change all the signs, and add. And I wind up with 2x to the 4th here. Notice that now I have this x to the 4th term that I wouldn't have seen had I not included it in my division. Now bring down the plus 0x to the 3rd. What times x gives me 2x to the 4th? Plus 2x to the 3rd. That gives me 2x to the 4th minus 4x to the 3rd. Change all my signs and add. And I wind up with 4x to the 3rd. Bring down the x squared term, plus 0x to the 3rd. What times x gives me 4x to the 3rd? 4x squared. So plus 4x squared gives me 4x to the 3rd minus 8x squared. Change all my signs and add 8x squared plus 0x. So plus 8x gives me 8x squared minus 16x. Change all my signs and add. And I have 16x minus 32. So plus 16 gives me 16x here and then minus 32. Draw my line. So I got a remainder of 0, which means that these are factors, so my answer needs to look like this. P of x, very quickly, equals the x minus 2 that I divided by times the answer that I got. X to the 4th plus 2x to the 3rd plus 4x squared plus 8x plus 16. There's your answer.